laser pointer.
Okay. So hi, thanks for showing up. I'm Steve Klein. I work with EPA in the Office of Research and Development in Corvallis, and this project is essentially a research demonstration to try and bring climate change into the regulatory world and be able to demonstrate through a pilot research project essentially how you could operationalize climate change in the context of TMDLs and the Clean Water Act, total maximum daily loads. And so in order to do this demonstration, we had to come up with a place, and in this case, the place was the South Fork Nooksack River, which is a rural-dominated watershed, mostly forest land use, small agricultural land use in northwest Washington, just shy of the Canadian border, and the Nooksack River system empties into the Puget Sound and Bellingham Bay. And in order to manage this watershed for the designated use, which are our salmon, we had to deal with temperature and flow as the main parameters that were being assessed, and look at how they relate to both the salmon and salmon habitat and the regulatory numeric standards. So in order to do this, we offered two innovations, and the two innovations were that one, we tried to deal with the Clean Water Act, the TMDL beneficial uses, and the ESA recovery planning concurrently, and then bringing in the USGCRP climate science. And so the world as it is, Clean Water Act TMDLs and ESA recovery actions are done separately in their own silo, even though they're really talking about the same endpoint of the risk assessment, which are salmonids. So in order to pull off this project, we structured it initially as a stakeholder-centric process where I and EPA were trying to facilitate that, but in a really elaborate partnership with federal, tribal, state, local, and NGO entities in order to give the research project that demonstration feel of real world and to be able to benefit from all of the knowledge and expertise that existed out there among the various stakeholders. And so the second guiding principle is all about demonstrating how cutting-edge science can be applied in a real-world problem-solving context. I added just recently, what is that? That's actionable science. And with the participation, the co-production of knowledge of scientists, environmental practitioners, and stakeholders. So the notion of actionable science and co-production of knowledge is new and are used often, but this project was really designed with those two notions in mind. So instead of dealing with a research pilot where there was a firm footing in policy, law, and regulation, we're essentially demonstrating how you could incorporate climate change into a regulatory framework. But the reality is that there's key challenges to incorporating climate change, particularly in the regulatory framework, because these approaches and laws and policies were developed under stationarity, and so non-stationarity climate change is new. It may not be new to people in this room, but it's new to the regulatory world. Risk and uncertainty are unavoidable attributes of climate change. Scenario-based risk assessments where a range of outcomes are considered are uncommon, and the representation of time as an explicit variable of scenarios is also uncommon. And the last point I wanted to make is that the application of climate change and climate change adaptation requires judgment and discretion by decision makers. And you can imagine in our current political climate, the words judgment and discretion in a regulatory world are really foreign. And so that makes it a huge challenge in a social political sense to incorporate climate change into our regulatory frameworks. So here's a very familiar graphic which really points out this notion of a scenario. We have a range of outcomes, the gray zone from high emission to low emission. We have time steps, and we have scenarios. And although this has been replaced by the RCP framework versus SRES, that this whole notion of a storyline, a range of outcomes, and an explicit representation of time is not common. And I would venture you could go out on the street and ask 10 people to interpret this graph, and probably 9 of them would walk away. So instead of hypothesis-driven research, this is objective-driven research, and that it's a research demonstration. And these are the objectives that we set out to achieve in the research pilot. And I won't read them to you, but you can imagine they're very operational in nature, and so being able to measure the success of the project will be how well we actually achieve those objectives. And then the last point is the desired project outcome, goal statement there, and very real world and operationally oriented. So in order to deal with the risk matrix and risk assessment, I was fortunate to be involved with the National Climate Assessment early and to see how they were thinking about the notion of risk, the magnitude of consequences, and the likelihood of impact. And this particular example was constructed to deal with a wastewater treatment expansion facility in New York City. And so they were looking at, okay, we're going to put in a new wastewater treatment facility. Let's look at climate change, in particular sea level rise, and ask ourselves for the duration of life of this expansion, where we are. Are we in a low probability, low magnitude, or medium probability, high consequence? And basically where you are in that matrix determines whether you are watching, developing strategies, or developing and implementing strategies, meaning adaptation. And so what we added was this notion of time, 2020, 2040, 2080, and we also added a range of outcomes, the green being the low emission, low impact scenario, a medium impact scenario, and a high impact scenario. And so by imposing both time and a range of outcomes, we're able to map in a risk way and be able to describe, where, how, and why we're dealing with risk and the magnitude of consequences and the likelihood of impact. And so in order to bring this research pilot into the world, I reached back into EPA's own risk assessment past. And you may not know this, or you may know this, so that EPA was essentially developed on the risk assessment paradigm. The early work was the human health risk assessment. In the 80s, it was expanded to the ecological risk assessment. And so this project, we added on the notion of climate change and came up with a climate change ecological risk assessment. But the same process holds, and being able to, do the problem formulation, look at exposure and effects, look at what climate change vulnerability is. In the old world, it was called risk characterization. And then you flow down to the green boxes below, communicating the risk, the vulnerability to the risk managers from the risk assessors, in this case the research pilot, and then being able to display to the risk managers the risk management options, and in this case, risk management are really climate change adaptation actions. So I can't tell you how many times I've used this slide and how many times it has been rejected in various briefings and documents. And I always thought that was rather strange, and the strange part is this, is that many of EPA's regulations were developed using the risk assessment paradigm, but it is atypical to use the risk assessment to implement the regulations. So that's kind of a paradox. So, again, why is it so hard to do this climate change work in the regulatory world? If we look to laws, if we look to regulations, if we look to policy and guidance, and we look to the compliance and enforcement framework, then almost none of this exists. And so we're basically out there demonstrating something that has no basis, at least in laws, policies, and regulations. And so you can imagine, I don't think I've seen any movement in Congress to offer up climate change amendments to the Clean Water Act or climate change amendments to the ESA. And so, we're forging ahead in this very complex area of science, trying to implement it in the real regulatory world, but there's really no basis in laws, policy, and regulation. So in order to do this risk assessment, we broke down the project into a quantitative assessment to address the numeric cold water standard, and we're able to model stream flow and stream temperature to meet the regulatory requirement of the numeric standard. But we also entered into a qualitative assessment, which was a freshwater habitat assessment of all of the other factors beside water temperature and related to water temperature that are key to salmon survival and persistence under climate change. And that part of the assessment, the qualitative assessment, was led by the Nooksack Indian tribe, as they were the original authors of the ESA recovery plan in that watershed. So together, it's really a robust programmatic approach, but it's really robust from an ecological perspective, and so we're right on target there. But in order to do a research pilot and in a regulatory construct, that we had to develop a way to pursue both the research activities and analyses, the top thread, and the regulatory timeline, so that we could shadow one another and so we could pass information back and forth, but that we weren't totally dependent on one another. And so the right hand of it is we're getting to the point where the actual draft TMDL is about to be issued by the state of Washington, and all of the studies and analyses that were part of this project are in fact part and parcel of that regulatory filing. So, like I said, there was strong tribal involvement by the Nooksack Indian tribe and the Lummi Nation, and I was fortunate to visit the ATNI Climate Leaders Summit in March there, and very interesting in that a session in Portland, that before we could have conversations about climate change adaptation, that we really had to address the underlying concerns that the tribes had to articulate their underlying concerns of self-determination, sovereignty, and treaty rights, and that people, place, and natural resources are inseparable. And so this lets you know that to get to the climate change adaptation story, that you have to work through those higher level concerns and issues. The other part of this that made this doable is that we were coming off a best case temperature TMDL from the state of Washington. So we weren't going from a blank piece of paper, we were going from a best practice by the state of Washington, and so this really helped make it robust and jumpstart. But in order to do this climate change work, we have to take a decision framework, in this case the TMDL pilot, the TMDL process, the regulatory process, and then map the climate change vulnerability process onto the decision-making framework in order to give them the answer in a way that was relevant to that decision framework or regulatory process. And again, we went through these three scenarios of both dealing with both time and different emission impacts to be able to offer a range of outcomes and risk. That all of this work was then modeled in a quantitative sense, and we had partnered with the Climate Impacts Group in Washington in their CMIP3 work. We're able to take that, to incorporate that, to use all of the VIC realization to all impose a set of boundary conditions on the climate change Qual2K stream temperature model, and then to compare that from the bottom, which is a calibrated current condition model, calibrated and validated for the South Fork. So we were able to see the difference by comparison between the climate future and the current condition. And what we found when we looked at maximum stream temperature, current condition versus 2080s, is that the warmer temperature or warmer colors you're seeing in the 2080s are really a result of and an expression of the change in hydrologic regime, moving from snow dominated to transition to rain dominated. So it produced a set of results, the left being full shade, the right being current shade, which shows those three squiggly lines of the three scenarios. And what that points to is that the red line and the red dashed line are lethal limits for salmon. So we're really skirting at lethal limits, and that shade everywhere only buys us 2 degrees, but in general it kept us below those thresholds for mortality. So in order to do the research demonstration, we've turned the quantitative work into a methods manual that'll be released concurrently with the draft TMDL, making this reproducible and repeatable and getting more utility out of a research pilot. That the ESA portion of that was the same thing, taking a climate change vulnerability assessment and adaptation planning process and mapping that onto the ESA salmon recovery process. And what that means is the logical input of this information would influence the 10-year update to the recovery plan. And so in the qualitative assessment, we dealt with risk being the horizontal bars and various classes of restoration activities. Came off Tim Beachy's work from the NOAA Fisheries Science Center, and we're able to map out in a tactical way how to deal with climate change, how to deal with climate change risk, and how to prioritize stream restoration with an explicit reference to how it affects and reduces risk. And we had to deal with individual species, their life history, the risk itself, as far as when it occurs in time and what risk. And then here's what makes it all possible, is that we don't have to get it right. We're not making all decisions for all times. What we're doing is setting up a context for adaptation, where in a context of an iterative risk assessment and an adaptive management framework, that we can repeat and iterate this through time as new information is available, as decision makers want to revisit decisions. And so this same process will be iterating or evolving over the decades. Thank you. Yeah, and are there any questions out there? I'll take a couple.
Could you just go back about 3 slides? Great, thanks. That was the one slide I
Yeah, so essentially the construct there was to take the horizontal bars, which were the risks of increased temperature, decreased flow, increased peak flow, and reverse diversity, and the vertical columns are classes of restoration actions, and then asking ourselves, is there a positive no effect or context dependent effect on how those particular restoration actions ameliorate or reduce the effect of the climate change risk?
Do you and your EPA have plans to apply this model to other watersheds, other salmon watersheds?
Well, I think we do in the context of our other partners, including the Nooksack Indian tribe. So they're interested in bringing this to the other forks of the Nooksack. It is easily transferable to the entire Puget Sound, more generally to any salmonid assessment. And the risk assessment paradigm is applicable to other risks beside temperature. It could be pathogens, it could be nutrients. You could use the same process. You could even be in Ohio versus Oregon, and so it does have general applicability.
I think that NOAA Fisheries is doing the Section 7 consultation with EPA and the state of Oregon for the Lower Columbia and the Willamette rivers on temperature.
Right.
Temperature, thermal refugia in the Lower Columbia right now.
Right. And so that was another challenge of this project, is that there are other things going on in the regulatory world in real time with this research pilot. And, well, thank you, and I guess I'll give the way to a colleague, Oliver Graf from the Nooksack Indian tribe, who was part and parcel of this project and has other climate work going on in the Nooksack River.